Okay, good morning, everyone. Sorry about the little delay there. Couple of administrative things first. I had some issues with the time zone on the class. I got it fixed. I sent an email out about that this morning. If that caused a problem for you in the homework last night, then you have until the end of today to get it done. So I hope that that kind of fixes that. Today we're going to do R8, the last day of review material, and then we're going to start 1.4. But as soon as we get into 1.4, the first thing we're going to do is review a few things that you need in order to do 1.4. So there will be a lot of reviewing of stuff that will be necessary today. So it's going to be important that you let me know if there's certain items that you're not comfortable with. That way we can identify, what you need to go get help for, tutoring, things like that. Homework for R8 and 1.4 is due on Sunday at 11:59 p.m. So two sections worth of homework this weekend. And then on Monday, we will start 3.1. I don't think we're going to finish 1.4 today. I don't think we will. So if we don't, I will adjust the homework, and I'll tell you only do up through this many problems. So when you submit it, it'll give you, a lower grade because you don't have everything done, but don't worry about that. We'll fix that, once we cover everything, I'll let you go back and finish it up. Okay, that's it. Any questions before I begin? Ready to roll? Okay, so we're going to start with review for section 8 of the review, and this has to do with two concepts: nth roots and rational exponents. So again, this is a lot of review material. I've got the definition, a lot of definitions here for us, or if you like, you can look at these as formulas. Remember what the principal nth root of a number means. So here's the notation we use: the nth root of some number a. If we say that that's equal to b, what we mean by that is that the a that's underneath the root is equal to b to the n power. Okay, all right, what do we mean here? We mean if you write down the cube root of 8, that is equal to 2. Why? Because when you take 2 and cube it, you get the 8. So the way I look at it is this: I say, all right, if somebody's asking me what this is, I'm looking at this number 8 and I'm looking at the number 3, and I'm saying, what number can I come up with that when I multiply it times itself 3 times, I will get the number 8? So that will be 2, because 2 times 2 times 2 gives you 8. So that's what the principal nth root of a number is. Now, if you have something like this notation, I'm sure all of you are familiar with that. That is the square root of a number. And we don't put the number outside here. Like in the formula, there's an n out here, but here there's nothing out here. So it's implied, it's understood. We all understand that there's a 2 here. We just don't write it. All right. So if it's not there, it's a 2. And so we're trying to think of a number that when you multiply it times itself twice, you get 4. So the answer here is also 2. That all look familiar to you? The idea of this root, this nth root of a number? Let's do one more. Let's see. What would the fourth root of 81 be? Who's got that for me? No calculator. Do it in your head. What number times itself 4 times gives you 81? Who's going to be my volunteer today?
3.
I'm sorry, Diego. What was that?
Number 3.
I couldn't understand what you said.
3. The number 3.
Okay. Right. Yes. Thank you. I hear that now. Thank you. 3. Okay. And the reason why that's true is because when you do 3 to the 4th, in other words, if you do 3 times 3 times 3 times 3, you get 81. All right. That's what the principal root is. So we should be familiar with that notation and what it means. Now, there are some important properties with nth roots. And that is, if you take the nth root of a number that's raised to the nth power, the root and the power kind of kill each other off. But we have to be careful. This is not exactly always like just, it doesn't always just spit the number out. So let me do this example of this first one right here. It says, let's say we take the cube root of, let's say, 5 to the third power. This property says, okay, well, that's just 5 then. It's like the root and the power kill each other off, and you just get the number 5. That will be the case if the root out here is an odd number. It has to be odd. So this would be the same for like the 5th root or the 7th root or the 9th root. It would always just kill each other off and give you the number. Where it gets a little tricky is when the power out there on the root is an even number. If the power is even and that number is even, then it doesn't spit out the number, it spits out the absolute value of the number. So let me show you an example of that. Let's say we take the 4th root of 81, right? Sorry, let's do it this way. The 4th root of 3 to the 4th. According to this property, right, because this is an even number out here, the answer should be the absolute value of 3, which of course is 3, all right? Now, why is that important, the absolute value? Watch, if I change the problem to this, if I put the 4th root of -3 to the 4th, the answer is not -3. Okay, so it doesn't just, these don't just kill each other off and you get -3. That's not what happens. What you get is the absolute value of -3, which is also 3. Okay, so you have to be a little bit careful when this power out here, or the radical, the root is an even number. It always spits, well, you also have to have the same power here. Then they kill each other off and you get the absolute value of that number. Okay, these are just, I'm just reviewing these things, then we're going to go do the problems. A few more things to review here. Some notation, some more notation. So what does it mean to take a number and raise it to a fractional power? Well, it means you take the nth root of that number. So here, I'll give you an example. If I write 9 to the 1/2 power, all right, here A is 9, the n is 2. This is the same as the square root of 9. You don't need to write the 2 here because it's a square root, but this would be equal to 3. If I write the, let's go 27 to the 1/3, that would be what root here? Let's see, Diego's already played today. How about Gloria? You're back. Is Gloria here? There you are. How you doing, Gloria? Good. So Gloria, what would be the number on the outside of this radical according to this formula here?
I'm not sure.
I'm sorry, I can't hear you.
I'm not sure.
You're not sure? Okay, so just look at the formula here. The A is the 27, right?
Mm-hmm.
Then you have 1, here's 1. And then here you have the n here for us would be 3, right?
Mm-hmm.
And according to the formula, this should be equal to a radical with the n on the outside of the radical. So what numbers are n?
It would be 3.
3, okay, so this would be the cube root or the 3rd root. And then inside, Gloria, what number is on the inside?
27.
27, okay, good. So if you take 27 and raise it to the 1/3 power, it's the same as saying, what is the cube root of 27? And can Zane tell me what that is?
Is it 3?
It's 3, right? Because Zane, what you're saying here is that what number times itself 3 times gives you 27, right? So you go, okay, 3 times 3 times 3. So this will be 3. Okay. So this right here, this formula is just to make sure we understand that when you raise a number to a fraction like 1/n, it really means you're taking the nth root. Now we can extend this just a little bit, this formula, if we use that same formula, but notice this difference. I'm going to now, instead of putting a 1 on top of the n, I'm putting an m on top of the n. So see here, that was a 1, it was a raised to the 1/n. Here it's a raised to the m/n. This is what it's equal to. So let me write an example down. Let's go 8 raised to the 2 divided by 3. 8 raised to the 2/3. According to this formula, the m is the 2 and the 3 is the n. So let's see, Ashley, are you here? Ashley T?
Yes.
There you are. Okay. Can you see, or looks like you're?
Yes, I can. Yes, I can. I texted you, sir.
Oh, you did? Text me or chat?
I said chat, yeah.
Okay, you sent chat. Okay, all right. Well, hey, cool. Just no, I'll get back to you. Okay.
Okay.
All right. Let's see. Isabella? You there? You there? Isabella? Isabella? How about Raquel?
Uh-huh.
Hey, Raquel, can you see what I'm doing? Everything?
Yes.
Okay, so what I'm asking you here is, can you tell me what this, rewrite this 8 to the 2/3 using that formula right there? What would it be? The what root? So what root am I going to put on the outside?
Wouldn't it be 2?
2, okay. And then I'm going to put here a to the m. So for us, a is the what?
The 8.
8, and then I'm going to raise that to what power?
The 3rd.
3rd power. Okay. So notice these two numbers are not the same, right? They're not the same, so they don't kill each other off, like in the previous property. So right now, we have the option. We can take 8 and cube it. So we can do 8 times 8 times 8 and see what that is, and then take the square root, all right? But that number is going to get big, isn't it? 8 times 8 times 8. That's going to be a big number. I might need my calculator. So now what I'd like to, instead of doing that, I'd like to look at the other way we could do it. And let's see.
I have a question.
Yes, go ahead.
So the 3, you have it pointing to the n, and it says outside of the radical, it should be a 3. But outside of
Oh,
the
wait,
radical.
hold on. I'm sorry. I got that wrong. I apologize. Oops. Thank you, Lizette. I don't know why I'm, okay, so let's go back. Who did I call on? Raquel. It was Raquel, right?
Yes.
Okay, so Raquel, I asked you what went on the outside of the root, right? And you said 2, and I said that was correct. Okay, be careful. Look, the n here, right? The n that goes on the outside of the radical is the denominator of this fraction, right? It's the number on the bottom,
Oh,
which
yeah.
would be which would be your 3, right?
And then the 2 would go
And
inside.
then the 2 goes here. Yes, I apologize. The denominator of the fraction is always the outside of the radical, okay? And the numerator is always the power on the number. Thank you, Lizette, for pointing that out. I would have caught it on this next one, I think. Because who was going to help me on this next one? Did I call anyone or no? I think I wanted to call on Miguel. Is Miguel there?
Yeah, I'm here.
Okay. So Miguel, if I asked you to do this last form, how would you write it that way?
You just put the square on the outside of the parentheses.
Yeah, so you keep the 3 on the radical, you put the 8 here, but instead of putting the squared inside with the 8, this property says you can do this and then square. So what this is basically saying is that if you have a number to a fraction, you can write that in two different ways. You can write it this way or this way. It's up to you. Now I'm going to show you, I'm gonna finish doing it both ways, and I'm gonna see, which way do you like better? So if I do this, I would do cube root, and then I would square the 8, which would be 64, right? 8 times 8. And now what I have to do is figure out what number times itself 3 times gives me 64, which would be the number 4, right? 4 times 4 is 16, times 4 again is 64. So I get the answer here 4, but that was a little bit tricky because I had to know that 4 times 4 times 4 gave me 64. Look at this way. This way I think is easier because the first thing you do is figure out what the cube root of 8 is. So what number times itself 3 times gives you 8? Well, that's 2, right? And then you square that, and that gives you 4. So you get the same answer doing it, it's your choice either way. Are there questions on that? So the main thing to remember here is that a number raised to a fractional power is really just a radical, all right? And you have 2 different ways you can write it. That comes up a lot in calculus. And which one of these you use is kind of up to you, all right? All right, let me see the next thing. Yeah. Okay, so now let's go take a look at the homework for this. Make this bigger. All right, so the first problem asks us to evaluate -4 squared and -4 squared. So it wants us basically to understand the difference between these two. And I believe we talked a little bit about this last time. This one right here means -4 times -4, which should give you positive 16, because a negative times negative is positive. This one, on the other hand, really means -1 times 4 squared. It's important that that negative is not in a parentheses with the 4. So that negative really acts like a -1 on the outside. And then that would become -1 times 16, which is -16. So we get 2 different answers depending on whether or not we have a parentheses or not. Very important. So this answer would be 16. And the other way is -16. All right, let's take a look at the next question. All right. Now, we haven't talked about this, okay? I did a quick review of exponents and the radicals and stuff. We have not talked about this yet, but this is a review topic. It's asking us to rationalize the denominator of the expression. So I know some of you have some experience with this already in the past. Can somebody tell me what rationalizing the denominator means? Like, what is it that they're asking us to do here? Does anyone know? No? Okay, let me ask you this then. If I write 1 over the square root of 2, let's say I work out a problem and I get this as an answer. Is that okay for me to leave that answer like that? Can I leave it with square root of 2 in the denominator? So let's take a vote. Yes or no? Can I leave it like that, or do I have to do something else? All right. Almost all of you have participated. There we go. Okay, that's good enough. That's enough of you. So there's the results. 88% of you say that I can't leave it this way. And 13% out there, 2 out of 16 have said that, yeah, you can leave it like that. So of the 88% of you, right, the 14 of you said, I can't leave it like that. Why can't I? Is that what you were told? Did someone tell you you can't leave it like that? What's the deal here?
Isn't it because you can simplify the 2?
What do you mean simplify it? Like on my calculator or?
Sorry, square root it.
Yeah, like I could do the square root of 2 and that would give me some decimal. I'd have to use my calculator, right? I could do that. I mean, that I could do, but I'm saying if you ever get an answer and you have a square root in the denominator like this, is it okay to leave it like that? And 14 of you, 88% of you saying, no, I cannot. And I'm wondering why you said no.
Because you have to rationalize the denominator.
Because you have to rationalize it. Okay.
Yeah.
I'm hoping that's what a lot of you, that's the reason why, is because you were taught you can't. A lot of times students are taught you cannot leave a square root in the denominator. That's what you're taught. Okay. And I'm here to tell you that that's incorrect. Okay. You are allowed to leave a square root in the denominator. There's nothing wrong with leaving it like that. All right. However, there is something you can do called rationalizing it. You don't have to do it, but you can do it. All right. And here's what it is. You take this fraction and you multiply it by 1, which shouldn't change the fraction, right? It's not going to change the answer. You multiply anything by 1, you should get the same answer. But the one that I'm going to choose is a very weird one. I'm going to choose square root of 2 over square root of 2. Now, the reason I'm doing that is this. If I multiply across the top, I get square root of 2. And on the bottom, don't I get the square root of 2, but it's going to be squared, it's times itself, right? Which will get rid of the square root of 2, right? That'll just make this square root of 2 over 2. I did not have to do that step. I know a lot of you are taught that you have to, but I don't have to. And here's why. Here's the original answer. Here's the other version of the answer. If you get on your calculator, if you have your calculator out, do this. Do 1 divided by the square root of 2, and you're going to get an answer. All right. After you do that, do the square root of 2 divided by 2 on your calculator, and you should get the same answer. Does anyone have it? Anyone try it on their calculator? As a decimal? What do you got? Anyone?
I got the same answer for both.
Okay, what did you get though as a decimal? What did you get?
0.707.
You got 0.707, something like that?
Yeah, something like that, and then it goes on 107.
Yeah, it keeps going,
Yeah.
right?
Yeah.
Okay, so look, it's gonna take me like 5-10 minutes to explain this to you, and this is time we really don't have to talk about this, but I think it's important for us to discuss. A lot of students are taught that you cannot leave it like this, and you must turn it into this. And most textbooks will do that. They will turn that yellow one into the green one. All right. I want to explain to you why. All right. I want to explain to you why they do it. It's not necessary, but I'm going to explain to you why. So back in the day, okay, before calculators were just something you'd have on your desk, right? Back before calculators, back in the what? 30s, 40s, 50s, right? Before computers were readily available to people, anyone that was taking a math class or doing math in their real life had to figure out what this was, right? And the square root of 2 is not something they can just go turn and type into something. So people in math had to memorize certain things, like they had to memorize the square root of 2. It comes up so much in math, they would have to remember that that's about 1.414. And they would have to, all the important numbers in math, they would have to just memorize them, like pi They would have to know that that's about 3.1415. E, they would have to memorize is about 2.718. And all of the important numbers in math, they would have to memorize. And they used to actually have contests to see like who could memorize them out the most digits. Right? It was like a gauge of how big of a math dork you were, right? How big of a nerd you were to see how far you can memorize it. In fact, one of my colleagues that I work with claims that he's like in his 70s now, okay? But so he grew up in the 40s, 50s, and he memorized pi out 120 something digits. And I know it's true because he recited it out 60 digits to me, just right off the, just spit it out. So that they used to have these contests, right? So imagine you're back before calculators and you're trying, so I want you to put yourself back before the calculator was available, and imagine that you were in a math class and you had to figure out what this was, okay? To do this computation, here's what you would have to do. You would have to go to old school division. You'd have to put the 1 in here, and on the outside, because you've memorized the square root of 2, you would have to put 1.414 out here. And then you'd have to do old school division, right? You'd have to be like, okay, how many times does 1.414 go into 1? And you'd be like, okay, well, it doesn't because it's bigger than 1. So you put a decimal, you put a 0, and then you say, okay, how many times does 1.414 go into 10? I don't know. I mean, it's hard, right? That's a little hard to figure out. Would you agree? However, if you do it this way, if you rationalize a denominator first, now look at the problem this person has to do. They have to do old school division, right? Still old school division. But what number goes in the box? So here the 1 goes in, right? Because it's the numerator and you're dividing by the square root of 2.
Would
Here,
it be 2?
the root 2 goes in, right?
The root,
Inside
yeah,
the
the root
box.
2.
So
Yeah.
it's the 1.414. And what number's on the outside? The 2, right? Now look at this. Does 2 go into 1? No, right? So you put a decimal here. Now, does 2 go into 14? Yes, 7 times. So you put a 7 here. Then you put your 14. You do all this stuff and you mess around with it. This is much easier to do by hand. The reason it's easier to do by hand is because this number out here is not a decimal. Do you understand? It's a nice whole number. It's easy to divide by a nice whole number. It's not easy to divide by a decimal like this. So rationalizing the denominator was always what they did back in the day to make the mechanical division by hand easier. And unfortunately, that it was drilled into them like you always rationalize. This technique right here of doing this is called rationalizing the denominator. That they would always be told, you've got to rationalize the denominator, got to rationalize the denominator so you can do this. Well, that just kind of never went away. Teachers just kept on drilling it, and calculators came out, and you really didn't need it anymore, but they kept on saying it. And now it's just taught without any real like logic behind it. It's just do it. You're just told, do it. Don't leave it like that. But there's, if you look at why, now you understand you don't need it. Do you understand? Like we have calculators. So if I want to know what this is, well, I just get my calculator out. Okay. So it's a, what do you call that? A kind of an obsolete kind of idea. Understand? Okay. I got to get back to business. Now, I'm not telling you, okay, please don't take away from this, that I'm telling you that you don't need to ever rationalize. It's not useful. It's never anything you're ever going to need. All I want you to take away from this is don't let anyone ever tell you that you must rationalize, that you have to. That's not true. But it is a very useful technique. Okay, it is useful. Not necessarily in this class, but in calculus, it is. The ability to rationalize a denominator or numerator is something we need to know how to do. I did it yesterday in my Cal 1 class. So it's just something we need to become familiar with. All right, so with that said, let's go back to that example. Sorry about that little history thing, but I think it's important. I don't like it when you're told to do something or not do something, it's not explained why. So I'm going to take this expression here. Let me copy it. And I'm going to do rationalize the denominator. And so what that means is I want to rewrite this expression where I no longer have a square root anywhere in the denominator, okay? I do not want a square root at all in the denominator. It's okay if it's in the numerator, but not in the denominator. So here's what I'm gonna do. I'm gonna take square root of 2 over 1 minus root 3. And I'm going to multiply by 1, okay? But the one I'm going to choose is going to be very clever. Now, when I do this first example, if you've never seen this before, you're going to be like, why would I do that? And the reason why we do this is because it works, okay? So someone's already figured out that this works. Now you need to know that this is what you'll do. So what I'm going to do is I'm going to multiply, because I've got 2 terms over here, I'm going to multiply by something with 2 terms. Had this just been root 3, if it was just root 3, I would multiply the top and bottom by root 3. That's what I would do if it was just root 3. Unfortunately, it's not just root 3. It's all this other stuff. So what I'm going to multiply by, or not all this other stuff, it's 1 minus root 3. I'm going to multiply by something, here it is, 1 plus root 3. And I have to do that on the bottom and the top. Does anybody know what this is called? When you take something that has 2 terms and then it has subtraction, you change it to the same 2 terms, but addition. Does anyone know what that thing's called? My calculus class didn't know what it's called yesterday either. No? Okay, this is called the conjugate. The conjugate. The conjugate. So give me any 2 terms, doesn't matter what it is, a plus b. The conjugate is a minus b, okay? It's just, you just have a different sign in between the 2 terms. That's what a conjugate is. So here, this one had a minus between these 2. I wrote it with a plus, so this is called the conjugate of this. So I'm multiplying the top and bottom by the conjugate. Now, let's see why this is good and why it works and why things become nice. So I'm going to multiply the bottom. So I have to do like a FOIL down here. And then on the top, I'm going to have to distribute this root 2 through. All right, y'all ready for me to do this? I'm going to do the root 2 through the top first. So square root of 2 times 1 gives me root 2. And then I have a plus. All right, I'm going to call on somebody. Caitlin, you there?
Yeah, I'm here.
All right, Caitlin, I'm curious to know how you feel about multiplying the square root of 2 times that square root of 3. How do you feel about that?
I don't remember how to do that.
Okay, so when we multiply 2 roots together, Caitlin, what you do is, I'm trying to do root 2 times root 3, right? Like that?
Mhm.
Because this is multiplication, I can do the square root. I can put both the 2 and the 3 together under a single root and multiply the 2 together.
Oh, okay.
Okay, so that just becomes plus root 6. Understand?
Yeah.
Okay. I told you on the very beginning of this class, like, do not feel bad if you don't understand something. Just tell me, hey, I don't remember that. We go over it real quick. I promise you're not alone. All right, so that's that one, right? We've got the top distributed through. Now on the bottom, I have to FOIL this. I have to multiply this out. So I'm going to do this over here on the side. I want you all to see this really clearly. I'm doing the bottom. So I'm going to do like a FOIL or an expansion. I do 1 times 1, right? That gives me 1. Now, when I do 1 times root 3, it's going to give me, well, just 1 times root 3, that's root 3. And then when I do the middle ones, I get negative root 3 times 1. That gives me negative root 3. And then what about this last one? here to here. Can someone tell me what happens when I do negative root 3? I'm doing on the side here, negative root 3 times positive root 3. What's that going to give me?
Is it just -9? Next square root -9.
Yeah, this is just negative square root of 9, but what's the square root of 9? Sana, so what number times itself gives you 9?
3.
3, okay, so you just get -3. So this becomes -3. Does that make sense, everyone? Do y'all notice something that happens to the middle two terms? These middle two.
They cancel out.
They cancel. Guess what? Anytime you ever multiply something by its conjugate, the middle two terms always cancel. That's actually why we do it. We multiply by the conjugate because we know that the middle two terms will always go away. Okay? So all we're left with is 1 minus 3, that's -2. And that is now my answer. I have rationalized the denominator. My denominator no longer has a square root in it. My numerator does, but my denominator does not. Okay, we got to keep moving. We got a lot to do. Let's see here. Hold on, I want to look at. All right, let's do this one. I've got to move quicker, okay? It's important that we get through material today. So here we have an expression, we're trying to simplify this. So I want to point out that this is the cube root, right? Cube root. And then we have -27 times, that's multiplication in there, x to the 5th. First thing I'm going to do is I'm going to split this up into 2 radicals. Now you are allowed to do that. You're allowed to do that whenever you have multiplication inside of a radical. In other words, if you have the nth root of x times y, you can do the nth root of x times the nth root of y. This is a property of radicals that you need to know, that you should know, should have seen at some point. So that's what I'm doing here. I'm splitting this into 2 radicals. This right here is just the cube root of -27 is just what number times itself 3 times gives you -27, and that will be -3, because -3 times -3 times -3 gives me -27. The next one is a little bit more, not difficult, but you got to do a little thinking here. Here I have a 3 here, cube root, and here I have a 5. And since that 5 is bigger than the 3, I'm going to do one additional step here. I'm going to split this into 2 radicals. I'm going to do the cube root of x cubed times the cube root of x squared. So because this is a 5 and that's a 3, I want to rewrite the 5 as a 3 and a 2. So if I put these back together, I would get the x to the 5th. But by splitting them apart, I'm going to be able to use the property that this is equal to what? Dominic, what do we have there? What does that part right here turn into using the property from just a little bit earlier?
Property from earlier.
What is the cube root of x cubed? Where's Dominic?
It's just the x itself, correct?
Just x, yeah, it's just x, exactly. So that's why I split this up into a x cubed and an x squared. So I could use that property to rewrite this as -3, just x. And then this one, there's nothing more I can do. So I'm just going to leave it like this, and this will be my answer. So I took this, split it up. This was just a cube root of -27. This I broke into two pieces, used the property here. Here I can't do anything because the 2 is smaller than the 3, so I just leave it. And that's it. Questions? Oh, wrong one. Let's look at the next one. I'm going to skip that one. That one is a foil out. I think you could handle this. This one is the same thing. Let me write it out. I'm going to do this one. This one's not that bad. So this one, I'm going to, what they're asking us to do is to expand this out and simplify it. In other words, they want us to do this squared, which means we take it and multiply it times itself. Like that. What students will do that's wrong is they'll apply the square to each one of these and they'll just tell me, oh, this is the square root of x squared plus 12 squared, and they'll tell me that's x plus 144. And that's wrong. Anytime you have addition between two terms and you square it, you have to do this, and then you have to do your FOIL. So when I multiply the square root of x times the square root of x, I just get x. When I do square root of x times 12, I get 12 root x. And then when I do the middle one, 12 times root x, I get another 12 root x. And the last two terms, 12 times 12 is 144. And the only other thing I can do is put these two radicals together. I have 12 of these roots plus another 12 of those roots. This is 12 plus 12 is 24 of those roots plus 144. So that is the expansion of that expression. Are there any questions? I know I'm working through these a little fast. Here's what I can say. If this is all like making you feel very uncomfortable, then we really need to get you to a place where you, I mean, these are prerequisite topics. So you should have seen all of this at some point, and this should just be like a matter of, oh yeah, now I remember that. Oh, I've seen that. I feel better. Okay. But it shouldn't be like, I have no idea what you're doing. I've never seen this before. It's been 5 years. I don't know what to do, you know, because then everything else is just going to be such a struggle for you. So it's going to be important that you reach out for help if you need it. All right. I've said this before, said it last class, I'm saying it again. Okay, that one is pretty much an extension of this problem that we did earlier, where you simplify the radical, except we have one more thing. You simplify and you put together, you put them together. So you simplify this, you simplify that, and then you combine like terms. You see how many more questions I have. There's not many more. Rationalize the denominator. We did one of those. Rationalize the denominator. We did one of those. Rationalize the denominator. We did one of those. That's where you do the conjugate. That we've done. A number to a fractional power. We talked about that in the beginning, right? What does this turn into? We did an example of that. We did an example of that. And that's it. Okay, that's it for the review. All right, like I realize that there's going to be some gaps, and you know, like I said, there's going to be some things that you're uncomfortable with, but those are the basic ideas that we need to just get our feet off the ground here in this class. All right. I don't know. I mean, I've been teaching this class for a long time. I mean, I've been teaching math in college for a long time, and no matter how long I've ever been doing it, I always hate it when I feel like the bus is leaving the station and there's a bunch of people that aren't on the bus. And I can't tell in a Zoom class where we are. I'm trying to go by the reactions of your faces. And when I'm putting problems up there, I hate leaving students behind. If they're not up to speed, I hate it. But you know, my job here is to make sure that we get through Math 1414 to prepare you for pre-calc, prepare you for Calculus 1. And so the bus has to leave the station, all right? It has to. And I want everyone to be on board, but it's going to be up to you to get help on these topics if you're uncomfortable with them at all. All right. All right, come to my office hours. All right, we are going to move on. We've got to get to the new material, I guess. So today, the rest of today is about chapter 1, section 4, radical equations. So we are officially in the next section, 1.4, radical equations, equations of quadratic in form, and factorable equations. So the objectives of this section are that we have the ability to solve radical equations, then solve equations in quadratic form, and then solve equations by factoring. These are the 3 main objectives of this section. Now, in getting ready to do this section, there are some prerequisite concepts that everyone here has to know already coming in, or else it's going to be really hard. All right. Everyone here needs to know how to solve a linear equation. Like, I expect that you know how to do that. I'm going to do an example of one. All right. And I expect that you can solve a quadratic equation. All right. So let's do an example of each of these. And I cannot just do one example and that like encompasses the whole idea, but this will at least remind you of what I'm talking about when I say linear equation and quadratic equation. So let's start with the linear equation. A linear equation, first of all, has to have an equal sign in it to be an equation, right? And it's linear, meaning that we're going to see a variable in here. I'm going to use x, but that x will always be to the first power. We're not going to see any powers higher than 1 on the x. So here's an example of a linear equation. Let's do a real simple one first. 2x minus 3 equals 5. Like, that is just like a baby linear equation. I expect that everyone in here knows the process to solve this. The process would be isolate the x, add 3 to both sides, right? That would give you 2x equals 8. And then I would divide both sides by 2, and I would get x is 4. Everybody in here should be able to do that. I should not have to show those steps for that problem. You should know how to manipulate that. Let's do a harder one. So what I mean is, if we do a problem later and I get to this point, I probably won't show the steps. I'm just going to go to the answer. So I just want to make sure you understand the steps that are involved to get to the answer. Like, you've got to be able to do that. Here's a more difficult linear equation. How about 2 times x plus 3 minus x equals negative 4 minus parentheses 2x plus 1. Now, that's a more complicated linear equation, but it's still linear in the sense that, well, all the x's I see are all raised to the first power, right? None of them are squared, or there's no square roots. And there's an equal sign in here. So we have an equation that's linear. My expectation is that you know the steps to solve one of these. The steps are, first thing is you clear all parentheses from both sides, which means you distribute things through if you need to. Here I'll distribute a 2. Here I'll distribute a negative. So let's do that. You get 2x plus 6 minus x equals negative 4 plus 2x minus 1. All right, just distribution of things through. Then you collect like terms. So on the left side, I can put the x's together and get x, because 2x minus x is x, plus 6. On the right-hand side, I can only combine the minus 4 and minus 1 to give me minus 5. And then once I'm here, I have a choice. I can move my x's around. I can get all my x's on the left side or all my x's on the right side. It's kind of up to me. It's up to you. I'm going to choose to move my x's to the right side. So I'm going to subtract x on both sides. And that'll leave me with 6 equals x minus 5. And then I will add 5 to both sides to get the x by itself. So I get 11 equals x. So my answer is 11. So I just gave you 2 examples of solving linear equations. One of them very, very basic, the other one a little more involved. I hope that that all looks familiar to you and that you feel somewhat comfortable doing something like that. The next concept that you need to be able to do this section is you need to be able to solve quadratic equations. So let's go through and solve a couple of those. All right. Any questions on these two that I gave you? Okay, I'm going to solve some quadratics. So for quadratic equations, I'm going to do a couple of them. Let's try and do 4 of them. All right. So the first one I'm going to do, let's do this. X squared minus 4 equals 0. All right. This is a quadratic equation, meaning that, well, we have an equation, right? Equal sign in there. And we have a quadratic, meaning that the highest power we see on the X is a 2, quad meaning 2. So we have a quadratic equation. The way that you solve this actually depends on you at this point. It depends on how you were taught this particular equation. There's 2 ways to do it. One way to do it would be to add 4 to both sides. So add 4 on both sides, gets rid of the -4 on the left, appears on the right, and then take the square root on both sides. If you do this method, you got to make sure you do plus or minus. Anytime you're doing a square root, anytime you initiate a square root on both sides of an equation, you're the one who brings it in, then you have to do plus or minus. All right. So I get X equals plus or minus, and then the square root of 4 is 2. That's one way to do the problem. You get 2 answers, positive and -2. Another way to do this problem is to recognize X squared minus 4 is a difference of squares. Now, when I say difference of squares, remember what last class we were talking about simplifying the rational expressions, and you had to factor in some of those problems? Difference of squares did come up. So I am hoping you all remember that formula for this. X squared minus 4 becomes X plus 2X minus 2. And once you have it factored like this, you can set each of these factors equal to 0. You set X plus 2 equal to 0, X minus 2 equal to 0. And then those are just little linear equations. You just solve for X. So move the 2 over, move the -2, like get rid of it. So you add 2 to both sides and you get 2 answers, 2 and -2. Same 2 answers you get this way. Questions there? No? Let's look at the next one. Is that the same problem? Similar, but not the same, right? The big difference here is that I have X squared, I have minus. This is 4, this is 4X, right? So these are different. So the way I'm going to solve this one is I'm going to factor an X out of both. Since they both have an X, I can pull an X out. And once I pull an X out of both, now that it's factored and there's multiplication there, I can set each of these equal to 0. And now I have 2 little equations to solve. The first equation, I already have my answer. X is 0. And then over here, I have to add 4 to both sides to get 4. So I have 2 answers there, 4 and 0. So do you see by having this X here, it completely changes how I went about the problem, right? If there was no X, I either moved the 4 over and did square root, or I did difference of squares and got an answer. But by having an X here, I don't do that. I pull an X out, and then I just set each factor to 0. Questions on that one? No? Now, that's a third quadratic equation. That one's completely different because now you have the -5 in there. So you should recognize this from your homework last time, right? Your homework, you had to do a bunch of factoring, and I showed you that little method with the little X, and you come up with the numbers and do all that stuff, right? And I said, go practice, make sure you practice. All right, that's the way we're going to do this one. We are actually going to factor this side. We're going to factor. And now I'm not going to show the steps, okay? I'm going to assume that you would go do this. You would figure out that this is x minus 5 times x plus 1, and then equals 0. So you factor this side, and now you set each of those factors equal to 0. So you have two solutions here, 5 and -1. You'll understand I'm not showing this step, right? The factoring step, I'm not showing that, but I'm expecting that you could do that if you were given some time, yes? All right, we're gonna do one more, and then we're gonna get into the section. The last one, I'm gonna see if you can get this one. X squared equals 5x -6. I'm gonna give you like 3 minutes. I'm gonna send out the poll. When you're done, just click yes if you get to an answer. All right. I just want to see like where y'all are. Some of you are going to get this real quick. Some of you are never going to get it. So I just want to see when some people finish. So far, it looks like we've got about 7 people on the bus for this problem. 8 people. I'm going to go one more minute just to see where we are as a class in 1 minute. Okay, we're gonna go now. We've got 19 of 20, 20 of 20 have responded. So I think that's enough of the class. Let's do this. Can someone tell me the first step for this?
I subtracted the 5x from the right side and then put it on the left side, and then I added 6 on both sides.
Okay, very good, Javier. Javier did what you should do whenever you have a quadratic equation like this, which is move everything to one side first. Okay, get everything to one side so that you get equal 0. Now, on the previous 3 problems, I did that for you, right? I already had it equal to 0. So I wanted to see how you would handle this. Javier, perfect. Move everything to one side. And then it just becomes a factoring problem, right? Then you just factor this side. And when you factor that, be careful, you should get x minus 3, x minus 2. Minus 3, minus 2. I gave you that intentionally because a lot of times people will put minus 6 plus 1. That's wrong because this is a positive 6, not a negative 6. So be careful. And now you get two solutions. You set those both equal to 0, and you get 3 and 2 as your solutions. So just let me repoll. Oops. Let me repoll you. Just tell me the truth. Did you get 3 and 2? Yes or no? So we'll see what percentage of the class actually was able to get that. Okay. All right, good. So about 82% of you, 15 out of 18, got 3 and 2. Good. I want to do one more. Sorry. I said I wasn't going to do one more, but I want to do one more quadratic. What if we had x squared minus 5x, and then how about minus 4 equals 0? So if you try and do this using that method where you take the number in front here and you multiply and you get -4 here, and then you put that number in the middle down here, -5. You try and come up with two numbers and multiply to be this and add up to be this. Can you actually find those numbers? Not happening, right? You mess around with this as much as you want, you're not going to get it to work, right? You could do 4 and -1, that works, but they don't add up to be this, right? So you can't do that. And the only other real choices are like a 2 and a -2, but that adds up to be 0. So that doesn't work either, right? So this doesn't work. Everything I've given you up to this point has worked. We've been able to factor it or do something with it. So y'all tell me, what do you do when you have an equation like this, quadratic equation that you cannot factor it out yourself? You can't figure this out. What do you have to do? What do you use?
Would you use the conjugate?
Not conjugate. There's a formula we have to use, Javier, that you've learned somewhere in the past. This very important formula for solving quadratic equation. The quadratic formula. All right. So everyone here needs to know the quadratic formula. The quadratic formula says if you ever have an equation ax squared plus bx plus c equals 0. Okay, if you ever have an equation that ever looks like that, then the solutions to that equation, there are going to be either two solutions, one solution, or no solution, but they will be exactly -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. That look familiar, everyone? This formula? So in this class, on an exam, I would not provide you that formula. I would expect that you know it. All right. It would make a good tattoo. If you want to get a tattoo on your arm, permanent tattoo, you know, that's cool with me. I have no problem with that. All right, so I'm going to use that formula here. And if there are solutions, this formula will give me the solution. So I have to identify the numbers in front of x squared. So that right there, 1 is a. This right here is b, the -5. And the c for us is -4. So all I do is plug it into the formula. X equals -b. All right, Sierra. Did Sierra already play ball today? I don't think Sierra did.
Can you hear me?
Yep, I can hear you, Sierra. How are you doing?
Doing all right. Feeling a little bit under the weather.
Yeah, we got some people here that are not feeling well today. Do you
Yeah.
remember using the quadratic formula in the past?
I do remember using it, but I can't. Well, yeah, remember using it. I don't know
Okay.
by heart.
So let's start with this in green, negative b. Negative b in the formula is always the opposite of the b that we have, right? So what is
Right.
our b?
Our B would be +5, right?
Well, our b is the -5, right? That's what b is for us.
Yeah.
B is the -5. So in the formula, it would be the +5. Yes?
Right,
Is that what
yeah.
you meant? Yeah, okay. So that would be +5, then plus or minus. Now we do square root. Now we have to do b squared. So we take our -5 and square it, right? Which would give us 25.
Yes, sir.
And -4 times, I like to do it this way, a times c. I like to do 2 sets of parentheses. Is it Malak? Malak? I feel like I'm saying that wrong. Malik?
No, you're saying it right.
Malak, okay, Malak. All right, so what goes in here, Malak? These two things? Can you see it?
Yes.
Okay, so I have -4 times what?
Wouldn't it be the 1 or the X?
The 1. It would just be the number, so just 1. And then here would be the c, right?
Yes, the
Which would
-4.
be -4 or -4. Then all of this divided by 2 times our a, right? 1. Good. Okay, that's it. So now we have to just grind this thing out. All right. So 5 plus or minus the square root of 25. Now, let me tell you the way that I do this. If you have your own way, that's great. What I always like to do here is to figure out these three things is I look at how many minus signs I see. And if I see an even number of minus signs, I'm going to put a plus sign. And if I see an odd number of minus signs, I'm going to put a minus here. So since I only see 2 minuses, I'm going to put plus. And now I just multiply these numbers together. And I don't even care about their signs. I do 4 times 1 times 4, which would be 16. And then I divide that by 2. So I get 5 plus or minus the square root. I have to add 25 and 16 together. That's 30, 41. And divide that by 2. These are my 2 solutions. Okay. I could get on my calculator and get decimal answers. The important part of what I just did is to remind you that when you have a quadratic equation that you cannot factor, we have the quadratic formula. All right. Let me end this poll. All right, let's get into it. We only have 30 minutes left. Let's get into today's material. Right, today is about, where is it? Here we go. Radical equations, equations in quadratic form. First objective of today for this section is to solve radical equations. That means we need to make sure we know how to solve an equation that has a radical in it. All right, a radical within the equation. So here is the procedure. If you're trying to solve a radical equation, the method is to first isolate the root or isolate the radical. And when I say isolate, I mean get it on one side of the equation by itself. All right, so move it to one side. You get to choose which side, but just get it by itself on one side. And then all the other crap in the equation, get it to the other side. Once you do that, the second step is to raise both sides of the equation to a power that will eliminate the radical. So if the radical is a square root, you're going to square both sides. If the radical is a cube root, you're going to cube both sides. If the radical is a fourth root, you're going to raise both sides to the 4th power. So the radical always dictates what power we're raising things to. Once we do that, we're going to solve the equation, and then we will check our answers. And you must check your answers when you're solving radical equations. Always check your answers. All right, so let's do this first one. I'll leave the steps right there. So I look at this, I have to look at this, I have to realize I have a radical equation. First, I see an equal sign. That tells me, oh, I've got an equation, right? Then I see a radical. There it is, a cube root. So it is a radical equation. So my first step is to move the radical to one side of the equation. So in my first step, I'm going to rewrite it as the cube root of 2x minus 4 equals 2. So all I did here was added 2 to both sides, right? I said, oh, let's get rid of that 2. Let's add it, that negative 2. Let's get rid of it by moving it to the other side, making it positive 2. Okay, that's my first step. Second step, Annika, are you there? Annika, where's Annika? Hey, Annika, are you following?
Yes.
Okay, have you done radical equations in the past? Do you remember doing this?
Yes, kind of.
Okay. So I've isolated the radical. Step 2 is to raise both sides to a power to eliminate the radical. And the power we have to figure out. So Annika, are you comfortable with what power I should raise both sides to?
Would it be 3?
3. Yep, exactly, because it's the cube root. So what we're going to do is we're going to take this side of the equation and we're going to raise it to the third power, and whatever we do to one side, we have to do to both sides. And Annika, the reason we did that is because now we know that the cubing the cube root, right, will kill each other off. And so all you're left with is what on the left side, Annika?
Just the 2x minus 4.
There you go, 2x minus 4. And then what about the right-hand side?
You get 8.
You get 8. Good, perfect. One last question, Annika. When you look at this, what type of equation is this now? Is it linear, quadratic? Is it still a radical equation? What do we have here?
Quadratic.
Quad, sure. Do you see squared on the x?
Oh yeah, linear.
Linear, okay. So we now have a linear equation. So we're on step 3. Step 3 is to solve whatever we have. So for this, I'm going to solve this. I'm just going to put here, this is linear, just to remind you. And so to do linear equations, I just, get the x by itself. I'll add 4 to both sides. I'll divide both sides by 2. Make it x is 6. Okay. Step 4, I have to check my answer. What that means is I've got to go back to the original equation and write it down. You've got to go back to the original, everyone. And now replace your x with your answer 6 and make sure that it works. So I have the cube root of 2 times 6 minus 4 minus 2 equals 0. 2 times 6 is 12. Twelve minus 4 is 8. The cube root of 8 is 2. And 2 minus 2 is 0. It checks. I hate that you have to do this step, but for radical equations, you have to, because it is possible that the answer does not work. It is possible. Questions on that? Look at it, see that it's a radical equation, isolate the radical, raise both sides to the power to kill the radical, solve whatever equation's there, check your answer. Ready for our next example? All right, here we go. Zachary, you there?
Yes, I am.
Okay,
Scroll back up real quick.
so Zachary, is this a radical equation?
Yes,
Okay, it's a radical equation. First step is to do what?
it's isolate.
Okay, so do we need to do anything?
I don't think so.
Yeah, it's already isolated. So step one, check, it's already isolated, right? So let's move to step two. We're going to take this equation where the radical is isolated. And what are we going to do, Zachary?
I would square the x minus 7.
Both sides, right? We're going to
Yes, both sides.
square both sides of this and square the entire x minus 7. Does everyone see how I wrote this on the right-hand side? I didn't do this. I didn't do x squared minus 7 squared. I didn't like square each one. I squared the whole side of the equation. This would be incorrect. Good, Zachary. On the left side, Zachary, do you have, what do you have on the left side when you square the square root?
It would just be x minus 1.
Okay, good. Now, on the right-hand side, what are we going to do over there, Zachary?
It's x minus 7 times x minus 7.
Perfect. So you're going to have to do that whole like FOIL expanding, distributing thing over there, right?
Yes.
Okay. Good, Zachary. Let's work this out. I'm going to save us some time. I'm going to expand that for us. And I'm going to collect like terms. So I actually did that just in my head, but I would expect that you could get from here to here on your own, right? You just multiply all things out, collect your like terms, you should get that. This is the, yeah, this is still the second step, right? Third step. Let's see where we are here. Araceli, you there?
Yes.
Okay, you doing all right with this?
Yes.
Okay, so Araceli, my question to you, what is step 3?
Solve.
Okay, we're gonna solve. What type of equation is this, Araceli?
That one is I want to say it's a quadratic.
It is, right? Because we see a squared here, right? The squared.
Yes.
So since it's quadratic, the first step to solving quadratic is to move everything to one side. Everything to one side. So I think we should leave all of this crap over here and just move these over by subtracting an x and adding a 1. If we do that, it'll clear the left side. So I have to subtract an x and add a 1 on the right-hand side as well. Right, Araceli, does that make sense? Okay.
Yes.
So we have 0 equals x squared minus 15x plus 50. Okay. And now I'm hoping that that's going to factor, right? I'm hoping that if I do this over here and play that little game, it'll factor. It does. I'm not showing this, but it does factor to be x minus 5, x minus 10. And now I set each of these equal to 0. And you should get 2 answers, 5 and 10. Are there any questions up to this part right here? Is it making sense, like what I'm doing? Like, are you understanding the procedure? Yes? Fourth step, check your answers. Now we had 2 answers, so we have to check both. All right. Oh, well, that's what we have to do. Oops. Whoa. Okay. So I'm going to erase this over here. I'm going to check my answer right here. This is the problem. See if I can move this up just a little bit. There we go. So I'm going to check this step 4. So I'm checking. Let's check x equals 5 first. Okay. So if I plug in 5 into that original equation right here. It'd be 5 minus 1 equals 5 minus 2. I mean, sorry, 5 minus 7. Now, is this true? Well, this is square root of 5 minus 1 is 4. Does that equal to 5 take away 7 is -2, right? It's a negative number. And the square root of 4 is 2, but 2 is not equal to -2. They aren't the same. And this means that 5 is not a solution to this equation, so I need to throw it out. That's why we have to check, because you don't want to say the answer is 5 and then go build a bridge and then the bridge falls down because it was never a solution, right? So x equals 10, we check that. Square root of 10 minus 1 equals 10 minus 7. 10 minus 1 is 9, so square root of 9 equals 10 minus 7 is 3. And the square root of 9 is 3, and 3 equals 3, and that is correct. So our only solution to this is 10. This answer we got right here is called an extraneous solution. And you get extraneous solutions whenever you like square both sides of an equation, right? Didn't we square both sides? If you raise both sides of an equation to a power, there's always the possibility that you introduce extraneous solutions. It's just the nature of raising both sides of an equation to a power. And because of that, that's why we have to check our answers. Okay, we have another one here. There we go. So just by looking at this, let's see here. Henry, you there?
Yes.
You following along today?
Yes.
Okay, good. Henry, I like your name. It's my middle name. This is my grandfather's name. It's my dad's name. It's a great name. Do you pronounce it Henry? Does your family pronounce it Henry, or do they pronounce it like Henri or something?
It's Henry, but I usually go by Hank.
By what?
By Hank.
Okay. You're okay with me calling you Henry then? You're good?
Yeah, either one works.
Okay. All right. So Henry, when you look at this, do you see something kind of very different here than what we've had?
Yeah.
What's like the big kind of, wait a minute, hold on, what is it?
Is it that there's two radicals on one side?
Yeah, there's two radicals, right? There's two. So if our first step is to isolate the radical and there's two of them, that's not really possible because there's two of them, right? So if I move one of them to the other side, like if I isolate one, the other one's going to be on the other side. I'm never going to truly isolate it, right?
Right.
So what do you do here? Well, unfortunately, we have to just follow the procedure. We're going to isolate one of the radicals and we're just going to choose. So I'm going to say, let's isolate this one because it's positive. It's got a positive in front on this side. Let's move this radical to the other side. So let's just still follow the procedure, except we got two radicals to deal with. So I'm going to take this square root of 2x plus 3. And then when I move that radical to the other side, it becomes a positive square root of x plus 2. And then I had a 2 over there already. So all I'm doing here, everyone, is adding this radical on both sides, right? It goes away over here, and then it appears with the 2, so I put it like this. That seem reasonable? I mean, we're just isolating it, one of them, yeah? So what would we do next if we keep following the steps, Michelle? Yeah, Michelle, hey, how's it going, Michelle?
Yes, good.
So what's the second step? Once we've isolated the radical, what's the next step?
Would you square both sides?
Both sides, right? So look, the left side actually is going to be nice, right? When we square the square root, it's going to go away and we're happy about that. The right side is going to suck. And it's going to suck because we actually have to square that, which means we have to expand it, which means it's going to be ugly. But that's the nature of this type of problem, right? So squaring the left just gives me the 2x plus 3 because the root and the square go away. But on the right, I'm going to have to take this and multiply it times itself. So watch what happens here. I want to take our time through this multiplication because a lot of students have trouble with this. But I'm going to call on people to help me out here. How about this first multiplication here to here? Let's see, Ashley, are you somewhere where you can play with us today? Are you?
Yes, sir.
Okay. How do you feel about multiplying square root of x plus 2 times itself?
Don't you have to take it off the square root?
Yeah, exactly. Because when you do square root of x plus 2 times the square root of x plus 2, that's the same as square root of x plus 2 times itself means squared, which just kills off the root and gives you x plus 2.
Yeah. So it cancels out the square.
Yep. Good. Okay, that's right. You want to keep going? How about this times this?
Wouldn't it be, wait, are you talking about but then we already cancel the square root?
Well, when we multiplied these two together, we did. Right? Okay. But we have to distribute this in blue. We've got to distribute it to this one and then to this one. So what happens when you take positive 2 and multiply it times this root? It doesn't make the root doesn't go away this time, right?
No.
It just gives you
substitute it.
2 of those roots, right? That's all it gives you. Good.
Yes.
Good. You're off the hook. I'm gonna try to get through everyone today. How about Alyssa?
Yes, sir.
Okay, Alyssa's, what about the middle one? This multiplication here, when we go and do that, what would you get?
It's gonna be plus 2 times the square root of 2 plus x.
Yep. So you've got again the same thing, right? Two more of those things. And Alyssa, what about the last multiplication when you do the 2 times the 2?
Plus 4.
Good. Is everyone clear on that expansion? Multiplying all that out. Oh, that's ugly. Okay, well, it is what it is. So watch what I do here. Just watch what I do, and then we'll talk about it. Javier?
Yes, sir.
You've already kind of participated today, but have you had a chance to look at what I just did there?
Yeah, you added the 2 or the square roots of x plus 2, and then you added the 2 plus 4.
Yeah, I did 2 plus 4, and that gave me the 6. And then, like you said, I put these two together, right? Because they're the same radicals. I have 2 of them, then I have another 2 of them. I add them together, I get 4 of them. Good?
Yes, sir.
Okay, so Javier, I'm going to put it on you now. We did step 1, which was to isolate the radical. I'm sorry, step 1 was to isolate the radical. Then step 2 was to raise both sides to a power. We've got that. Step 3 is to solve. So Javier, and everybody think about this for a second. Javier, what type of equation are we trying to solve right now? What type of equation is this?
Linear equation, since it's no squared.
Okay, I agree that it's linear in the sense that there's no squares, but Javier, what is this?
Square root.
It's a radical, right?
Mm-hmm.
So Javier, how do you solve radical equations? Well, that's kind of what we're doing right now, right? We're in the middle of solving the radical equation, and we have to solve another radical equation. Yeah, exactly. So what are we going to have to do? First step of this is to do what?
Isolate the
Isolate the radical, right? we've got to do this again right now in the middle of this problem. We've got to isolate the radical again. This is the way this problem goes. It is what it is, right? So watch what I'm going to do. I'm going to now try and isolate the radical. So I'm right here at this step, we go, crap, this is a radical equation. So I got to go through and do the steps again, right? The 4 steps. So the first thing I'm going to do is isolate the radical. So that means I'm going to subtract x, subtract 6 from both sides. Subtract x, subtract 6. We should get x take away 3 equals 4 square root of x plus 2. All right. We almost, are there any questions on what I just did there? Just getting rid of the x's and the 6, bringing them to the other side. We almost have the radical by itself, right? Almost. Do y'all see there's a 4 in front of it? So I have a choice here. I can divide both sides by 4 right now. I can. Okay, I'm allowed to do that. That would be legal. But if I do that, I'm going to create a fraction over here, right? And I want us to avoid fractions because everyone freaks out when we have fractions. So instead, here's what I'm going to do. I'm going to square both sides now. All right, I'm going to square now, even though I have that 4 sitting out here attached. Watch what happens. When I square x minus 3, I have to FOIL it. Please understand from here to here, I'm not showing the work, ... But that is x minus 3 times x minus 3 in FOIL, right? That's what I'm doing there. Not showing that step. On the right-hand side, because there's multiplication right there, I can square the 4, which gives me 16. And then I can square the square root, which kills the square root. And I just have the x plus 2 there. But it's important because there's a 16 in front that when I kill the root, I leave the x plus 2 in parentheses. It's got to still be there so that the 16 can distribute through. Does that make sense? No? Distribute the 16 through. And let's see. Yeah, question what?
Yes. So how do you know when to FOIL? Like that was my big weakness last semester because I just didn't know like when it was right and when it was wrong. I just need to know like.
So you didn't know when to FOIL something out?
Yeah, like what does it have to do? Like I just understand FOILing.
Okay, so if you have 2 terms, see I have 2 terms, I have x and I have 3 and they're separated by a subtraction sign.
Okay.
That means anything that's separated by addition or subtraction creates terms. If you ever have 2 terms, in which case I do, I have 2 terms, and you square them, square this whole thing, then you have to write it out as that times itself. Oops. Okay, that's what that means. Now, then you do this thing, right? So are you asking me why do you do this? Like, what is this about? Or are you asking me like how to identify when to do this?
Kind of both, but I just didn't know like how to work it out, if that makes sense.
So
but now that I see that you're that you just, yeah, I see it.
There's all sorts of ways to learn how to do this multiplication. I mean, I've seen people that make charts, they put x here, 3 here, minus 3 here, x here, minus 3 here, and they do like a table, x squared, negative 3x, negative 3x, 9, put them all together. I've seen all sorts of things. All right, you have to do what's most comfortable to you. But I think what you're asking me is something we should talk about in office hours, like so I can clarify like the confusion that you're having.
Yes, it's like a 101 thing because I
Yeah,
just
I think
need
that
to know
is.
like step by step, I guess.
Yeah.
Okay.
So either visit my office hours, or everyone remember that there's also tutoring available through the college. You just go to the syllabus, there's Zoom links that you can go to. They're just sitting there waiting for people to come in and ask questions. So just remember that's available, because I know my office hours are not always going to work out with your life. So, all right, what do we have here? I'm just
Oh,
going
I
to
have
ask.
another question.
Yeah, go ahead.
Well, like, I don't mean to like, I feel like this is kind of rude for me to like correct you, but isn't it like 16x plus 32, not
Oh, did
plus
I put-
36?
I bet you if we watch the video, I said 32. I almost.
I'm pretty sure you
I'd be
did.
willing to bet I said 32. Hey, do not feel like you're being rude correcting me. Look, I know a lot of math. I'm not a calculator though. Like I'm a human being. Like I do stupid things. I make stupid mistakes, just like you do, right? Everyone makes stupid mistakes when it comes to math. All right. That stuff I'm not so worried about. Okay. I'm not worried about you do a problem and oops, you accidentally put 36 like I did. I'm worried when you get to this problem and you don't have any idea what to do, right? And you're just lost from the beginning. That's a different problem to deal with. So don't feel bad about correcting me. And good for you if you find it. That means you're paying attention. That means I know you're paying attention. It's a good thing. All right. All right. Now we have a quadratic equation, right? That's what we're looking at now. So we have a quadratic, and we can solve this by moving everything to one side. So I'm going to subtract 16x and subtract 32, subtract 16x, subtract 32. Gone, 0. And then over here, negative, what is that? Now you've got me all nervous. No, I'm kidding. So negative 22 and negative 23. I believe that's right. I'm almost out of time, so I have to finish this up. So this does factor x minus 23, x plus 1 equals 0. You set each of those to 0 and you get two answers, 21 or 23 and negative 1. Whew. Are we done? You have to check your answers. Okay. Now I'm almost out of time, so I'm not going to check them. I'm going to let you do that. But I need to go look at the homework real quick because there's no way you can do all of them. So let me just look real fast. 1.4. Just take a look at these questions. So y'all jot this down, okay? Because you're only going to do a few of these. You're going to do number 1, number 2, number 3, number 4. That's it. The first 4 problems for 1.4 are all you're going to do for homework. All right. And submit it. Okay. Even though you're going to get all these wrong. Okay. A bunch that you don't do wrong. Just do the first 4. And then after you've submitted it later on next week, I'll reopen the assignment. You can go back and finish the rest. But I want you to show me that you did the first 4. All right. For homework 1.4. All right. So look, I mean, we're kind of dragging a little bit, but it's okay. I mean, we'll try and make up some ground here. There's some places where we can make up ground. Today is the 26th, so we're supposed to be, right? It's 26. So we're supposed to be finishing 1.4 today. We're about a third of the way through 1.4. So we still have a lot to do in this section. But I think what we went through today, the notes, everything we did, I think that's enough to get you through, definitely get you through those first 4 problems. And then the R8, in the R8 review, there's a couple of things we didn't talk about to see how you do with that. Any questions?
Quick question, sir. For the tutoring, you said it's in the course syllabus.
It should be. Let me bring it up. If you need to go, you're free to go. Have a good weekend. Do your homework. See you next week. Expect a quiz. There could be a quiz next week. We haven't had one yet, right? We haven't had like a legitimate quiz yet. So, okay. So here's our course page. Go to the syllabus. Let's see what this does. Okay. Scroll down. Tutoring. Let me just click here and see what happens.
And then are we going, or I know this class it's all Zoom for the whole semester, but are we going back to in person next week?
Great question. I don't know the answer to that. I have not been told that we're not.
Okay.
Yeah, so
I
for
think
this
we
class,
are.
what's that, Jose?
I think we are. Well, I know from my home campus is Lakeview, and we are
Mhm.
going back on Monday.
Okay. They haven't given us any clear, at least, well, I haven't looked at my email this morning, but they as of yesterday had not given us any directive that one way or the other way. So I'm assuming, since they haven't told us yet, that we are going back. Now, yeah, like you said, this class, we're going to continue doing Zoom. But if you have any other classes that are face-to-face, from what I understand, if there's no change to anything, we are resuming classes next week on campus.
Okay, thank you.
Okay?
Wait, so this class is gonna be meeting in person next week?
No, we will never meet face-to-face.
Okay.
Yeah, this class is fully Zoom only. Yeah. It's just, you might have another class that you signed up for that is face-to-face.
Also, you said you extended the time for the homework from yesterday,
Mhm.
right? And we can finish it today?
Yes.
Okay.
So
Okay,
that was
thank
for
you.
R7.
Yeah, for R7, I was having some problems with that.
Yep.
I was gonna tell you about it, but you said it first thing in the morning, so.
Yeah, I don't know what happened. I set the
Yeah,
class
that's
up
kind of
at
weird. Yeah.
Central Time Zone, and then somewhere it got switched somewhere. So it should be fixed.
All right. Well, thank you, sir. Have a nice
Okay,
weekend.
have a good one. Anyone else? We're good? Okay. Caitlin, have a good one.